Here question number 16, the coagulation values in millimoles per liter of the electrolytes used for the coagulation of H2S3 are given below. This question is also asked in NEET 2016. My dear students, what is the concept theory? What is the concept and theory of this question? Here you can see the AS2S3 is the, my dear student, it is the negatively charged colloidal particle because my dear students, it accept sulfide -2 ions, and when this arsenic sulfide adsorbed sulfide -2 ions, it means it is a negatively charged colloidal particle. Now, what is the question, my dear students? Question is that coagulation values in millimoles per liter of the electrolyte and order the correct order of their coagulating power. My dear students, that electrolyte which is positively charged are the coagulate of this colloidal solution arsenic sulfide. So, number 1 is positively charged. We take the positively charged electrolyte. Number 2, my dear students, maximum magnitude is present. So, you can see the when this coagulating values is less means coagulating power is maximum, because we can see here coagulating power. This is the inversely proportional to coagulating values. So, my dear students, you can see here you can see the Na plus ions and Cl minus ions. Here you can see the +2, -1, and here you can see the Mg +2 and SO4 -2. So, coagulating power, here you can see the 0.22 values of coagulation. So, coagulating power is maximum in third when 0.22, but here you can see the 0.69 and 52 values is come coagulation value. But my dear students, here magnitude is +2 and magnitude here +1. So, third 2 and 1 is the correct answer, because in coagulation magnitude is also there, maximum magnitude is also there, oppositively charged is present, both are positively charged, but magnitude is greater. So, my dear students, you can see the question number 16 answer is C, and this question is also asked in NEET 2016, and this is the concept and theory, and by this theory and concept you can solve easily this type of questions which are asked in NEET exams. Now, when we see the question number 17, fog is a colloidal solution of, my dear students, what is a fog? Fog is a liquid, my dear students, and when liquid means water liquid, when water liquid present you can see here when water liquid present in air, then fog is developed. So, my dear students, when water present in air, then fog is developed. So, your answer is C, because liquid in gas, in air is the mixture of mixture of gases. My dear students, here air is the mixture of gases. So, this is the answer, question number 17, answer is C, air is the mixture of gases, and this question is asked in NEET 2016. Now, we can see the question number 18. Which property of the colloidal solution is independent of charge on the colloidal particles? My dear students, here concept and theory. Independent means these are not depends on the charge on the particle. Here you can see the electroosmosis, A option. Electroosmosis means, electro means it is related with charge, because when in electroosmosis electrons are present, then colloidal particles are moved through that electrode in which oppositively charged present. If you can see this is the electrode, my dear students, and here this is the oppositively charged electrode is present. So, this colloidal particles move through the negatively charged colloidal particles, negatively charged electrodes. This is the negatively charged electrodes, and here you can see the SPM is present, semi-permeable membrane. So, this is called electroosmosis. Now, we can see the coagulation. You can see the coagulation when you have the this electrolytes are added in a colloidal sol. Colloidal sol are positively charged particles, so colloidal sol is stable, and when you can add the electrolyte HCl or NaCl, then these are neutralized, these charges are neutralized, and colloidal particles are come close to each other and form a precipitate. So, my dear students, this property is also based on this charge. Now, we can here see that is the Tyndall effect. My dear students, this is the only and only one this property of colloidal solution, which is called Tyndall effect. This property is only depends on the size of the colloidal particles, size of the colloidal particles. So, this property is shown by lyophobic, not lyophilic, because size of the lyophobic colloidal particle is greater than lyophilic. So, my dear student, it is shown by only lyophobic colloidal particle, because here you can see the size, lyophobic colloidal particle size is greater than lyophilic. So, this property is only shown by this lyophobic, not lyophilic. So, my dear students, you can see here Tyndall effect is the depend upon the size of the colloidal particle, not depend upon the these charges. So, you can go the answer B, question number 18, and this question is also asked in 2015 as well as 2014, 2 year. Now, we can see the question number 19, my dear students. The protecting power of lyophilic colloidal sol is expressed in terms of, my dear students, here you can see the protecting power of lyophilic colloidal sol. It is depends upon this gold number, protecting power. Lyophilic colloidal sol, gold number is the minimum amount of lyophilic sol. Gold number is the minimum amount of lyophilic sol when 1 milliliter of 10% NaCl is added to 10% gold sol and protect and protect the coagulation. It is the minimum amount of lyophilic salt, amount of in gram. So my dear students, gold number is not a number of gold, it is not an oxidation number. Gold number is the protecting power, protect the coagulation. It is a protecting power when 10% gold salt, 1 milliliter of NaCl is added. My dear students, when you can see here, this is the, you can see here 10 milliliter. You can write here 10 milliliter gold salt is taken, and this gold salt is a, my dear students, a lyophobic colloidal salt, lyophobic, and you can well know that particle size of lyophobic is greater than lyophilic, and when this lyophilic colloidal salt are added in lyophobic, then this lyophilic form this protective layer. This type of layer is called this protective layer, and this protective layer is formed by the lyophilic. So my dear students, this lyophobic is protect from the electrolyte, because lyophilic is formed the layer on the lyophobic. When we can, what is the definition of this gold number? When we can take the 10 milliliter gold salt, which is lyophobic colloidal salt, and you can add the NaCl, and you can add this NaCl is act as electrolyte, and you can add the NaCl in a fixed amount, that is 1 milliliter of 10%. And when, my dear students, when you can add the 1 milliliter of 10% NaCl, then gold salt is converted into precipitate form. But further you can add the lyophilic salt, and lyophilic salt adsorbed by this lyophobic or adsorbed by this gold. Here this is the gold, and it is a lyophobic. Adsorbed by lyophilic, adsorb on this lyophobic and protect this lyophobic or gold salt from the 1 milliliter of 10% NaCl. So which amount? That amount is calculated by you in grams. That amount is called gold number. That amount is called gold number. Now my dear students, I give you this concept and this theory and definition. So my dear students, you can easily understood and you can easily solve the questions which are asked in NEET exams. And this question is also asked in 2012, that is question number 19, answer is B. Now my dear students, we can see here question number 20, which one of the following forms micelles in the aqueous solutions above certain concentrations. Here my dear students, you can see here do-decyl trimethyl ammonium chloride. My dear students, what is the concept and theory of this question? Concept and theory. First of all, you can see the do-decyl trimethyl ammonium chloride. Do-decyl means, my dear students, do-decyl. Do-decane means 12 carbon atom. Okay. So you can see here, this alkyl group is 12 carbon atom, 11 plus 12. So it is called do-decyl radical, do-decyl alkyl group. And my dear students, it is attached with this carbon atom, and this carbon atom and it is attached with this nitrogen atom, and this nitrogen atom 3 methyl groups are attached, and when these 3 methyl groups are attached, so it is called trimethyl ammonium, because positive charge is present, ammonium, and this is chloride. So my dear student, this is the structure formula of do-decyl trimethyl ammonium chloride, and this is used as a detergent, my dear students. It is used as a detergent, And when this detergent is dissolved in water to form a micelle, you know the micelle, this is the hydrocarbon part insoluble in water, but this part is a positive polar part which is dissolved in water. So, you can form this type of micelle, and this is the grease. All these molecules are attached with each other, and my dear students, you can see here this hydrocarbon part present in the grease. So, my dear students, this is the grease part, and this is the hydrocarbon tail. My dear students, this hydrocarbon tail dissolve in oil. This hydrocarbon tail dissolve in oil, and my dear student, this is the head, and my dear student, this head is dissolved in water. Head dissolve in water. So, my dear students, this is the detergents, and these detergents, you can see here these detergents dissolve in water to form a micelle, and this is called micelle. So, my dear students, this you can go the answer A, because question is that which one of the following forms micelles in aqueous solution above certain concentration, and above certain concentration it is also called CMC, critical micelle concentration. This question is asked in NEET 2005. Now, we can go to the question number 21. Here, my dear students, what is the position of non-polar and polar part in micelle? This theory is also already discussed in question number 20. Okay. So, polar part, when you can get the negative charge, this is the, my dear students, it is the polar part, and this hydrocarbon tail is the non-polar part. And you can see polar part is present on a surface and the non-polar part in a surface. Then you can go to the question number 21, you can go option A. Now, my dear students, this question is also asked in 2002. We can discuss the question number 22, which one of the following method is commonly used method for destruction of colloid. My dear students, that is the question number 22, you can go the answer D, because you can see this is the colloidal solution, and when in this colloidal solution we added the electrolyte, colloidal solution is formed and we can added the electrolyte. So, my dear students, electrolyte neutralize the colloidal particles and it is converted to precipitate form. So, this reaction is also called, my dear students, it is also called coagulation, or it is also called precipitation. So, here you can see the coagulation of precipitation. So, my dear students, here coagulation is done by the addition of this electrolyte, and this colloidal sol is converted to precipitate form, means colloidal sol is destruction of colloidal solutions take place. So, you can go the answer D, and this question is also asked in 2000. Now, my dear students, we can see here question number 23. This question is also asked in 1998. At the critical micelle concentration CMC, the surfactant molecules, my dear students, in CMC we can see before in the slides, these are the micelles, and you can see here some for the formation of micelle, some concentrations are necessary to formation of this micelle. This is called micelle and this is tail and head. So, my dear students, what is these are dissociated or associated? You can see here this micelle, when formation of micelle, these are the associated. So, you can go the answer A, question number 23, you can see the answer A. Now, my dear students, this question is also asked in 1998. Now, we can see here question number 24th, the ability of an ion to bring about coagulation of a given colloid depends upon. My dear students, it depends upon, we can see already see this theory and concept, magnitude and charge. When this you can see the As2S3 negatively charged colloidal particle, the negatively charged colloidal particle is coagulated by the positively charged, means AlCl3 coagulation power of aluminum chloride is greater than MgCl2, and my dear students, this coagulating power of magnesium chloride is greater than NaCl. My dear students, this is also called Hardy-Schulze rule. Hardy-Schulze rule. So, according to a Hardy-Schulze rule, we can see here colloidal particles is neutralized or coagulated by the addition of these electrolytes, and those electrolytes in which magnitude and number and charge, opposite charge are maximum, are electrolytes more than those electrolytes in which magnitude and charges are less. So, you can go the both magnitude and charges. And then ability of an ion, this is the anion, my dear students, bring about coagulation of a given colloid depends upon both magnitude and charge, and this is given by Hardy-Schulze. So, this rule is called Hardy-Schulze rule. Now, my dear students, we can go to the question number 25th. When a few typical solutes are separated by a particular selective membrane, such as protein particles, number 1 is the protein particles, number 2 blood corpuscles, and this process is known as, here solutes, typical solutes are separated by these particles. So, my dear students, you can see here, you can go the question number 25th, answer is C, because this is the purification of, you can see the purification of colloids, or you can see the purification of colloidal solution. My dear students, when you can see the purification of colloidal solution, in purification of colloidal solution, you can see marchment, this paper or marchment, this bag is placed in a beaker, and here electrodes are present, negatively charged electrodes are present. So, my dear students, here colloidal particles are not moved from this bag, because this bag is formed from semi-permeable membrane. So, here you can see we can draw this diagram in this way. And this semi-permeable membrane this is present, or bag is formed from this semi-permeable membrane SPM. So, my dear students, these colloidal particles are not moved from this side, only plus or minus charges are go from this SPM. This is the colloidal particles. And these colloidal particles are not moved from this bag. So, my dear students, you can see here this process is called dialysis. What is a dialysis? Dialysis is this process. So, I give you concept and theory, and you can see the theory of this dialysis. In dialysis, my dear students, we can see this marchment, this bag, Marchment bag or SPM bag, only electrolytes are moved from this bag, not colloidal particle. So, colloidal particles are present in this bag. So, this process is called dialysis, and you can purify of these colloidal particles. So, you can go the question number 25th, answer is C. This question is also asked in 1996. Now, my dear students, we can see here question number 26. Which one of the following emulsifying agent helps in the formation of emulsion? And here W upon O. My dear students, two type of emulsions are present. Concept and theory. Types of emulsions. Here, my dear students, when we can see the types of emulsion, number 1, W upon O means oil in water. When you say see that oil in water, it means oil present in, this is the oil present in is in axis, this is the oil, and you can add the water molecules or small water molecules you can add, and when this water is added, then water molecules are present in oil. So, my dear student, it is called oil in water. Now, second type of emulsion is called, this is called oil in water. It is called oil in water. Here oil in water, here water in oil. Here this is called water in oil. You can see here water in oil. Water in oil. And in second part, my dear students, you can see here oil in water. Oil in water. When you say here oil in water, we can present water in a beaker. Here this is the water. And my dear students, when this water, when oil is added in water, small oil is added in water, then you can get the oil droplets here. Oil droplets. So, these are called emulsions. So, emulsions of two types, number 1 water in oil, number 2 oil in water. My dear students, when these droplets are stable by the addition of some extra, droplets are stable by the addition of some extra substances. When we are added the some extra substances, then these droplets of oil, or my dear students, droplets of this water are stabilized, and these extra substances adsorb on these droplets. So, these droplets are stabilized, and this extra substance is called emulsifying agent. This extra substance is called emulsifying agent. So, what is the emulsifying agent? Helps in the formation of these emulsions. So, as emulsifying agents, my dear students, here you can see the insoluble soaps are used as a emulsifying agents. So, my dear students, this emulsifying agent is a substance, and those substances are insoluble soap, means calcium stearate or magnesium stearate are the insoluble soap. Insoluble soaps, calcium stearate and magnesium stearate and magnesium stearate are the insoluble soap. and work as a emulsifying agent. So, my dear students, your answer is insoluble soap, and this is the concept and theory of type of emulsion. I give you type of emulsion and what are the type of emulsion, what are the emulsifying agents. Now, my dear students, we can see the question number 27. The minimum concentration of an electrolyte which is able to cause coagulation of a sol is termed as it is. My dear students, when we can see the minimum concentration of an electrolyte which is able to cause coagulation, means colloidal sol here converted into precipitate form, then this process converted into precipitate form, then this process is called coagulation, and we are added the electrolyte. Concentration of electrolyte is called, my dear students, flocculation values, or my dear students, it is also called coagulation values, or it is also called coagulation values. So, you can go the answer C. Here question number 27, you can take the answer C. Now, my dear students, we can see the question number 28. Cottrell precipitator is a device. Yes, my dear students, this device is placed in a factories. Here you can see in factories, these are the chimneys are present, and my dear students, in these chimneys, here smokes are present, and in this chimney, here this Cottrell is present. This is the oppositively charged plate is present here in this chimney. So, my dear students, this diagram. Here this smoke is come, my dear students, from the factories, and here you can see here this whole part is converted to oppositively charged electrodes, this whole part. So, my dear students, here when smoke is come, and here electrodes, one of another electrode is placed. So, my dear students, here smoke, dust or carbon particles from the smoke is neutralized, and these carbon particles when neutralized, these are present in or deposited in this area, and you can get the dust particles. Here you can maximum type of dust are present, and you can separate this dust, and here these gases are free from carbon particles. So, my dear students, pollution is not there, free from carbon particles. So, my dear students, here you can see the smoke. In smoke, carbon particles are present and it is neutralized, and these are the neutralized are coagulated. So, you can see here Cottrell precipitator, you can go the question number 28, you go the answer B, coagulate the particles of carbon from smoke, and this is called Cottrell precipitator. So, my dear students, I give you concept and theory with tricks. I can give you concept and theory with tricks. Now, we can go the question number 29. My dear students, this question is also discussed by us. Question number 29th. Gold number is a what is the gold number? I already give you concept and theory already given before. And you can see gold number is the measure of protective action of a lyophilic colloidal on a lyophobic colloidal solution. Now we can go to the question number 30. Which of the following statement is correct? You can see here not correct statement. Under this correct statement, you can see the correct statement number 1. A. True particles are able to pass, that is through filter paper and not in semi-permeable membrane. My dear students, what is the concept and theory? Here you can see the true solution or true particles. True particles are present in true solution, my dear students. True particles are present in true solutions. And number second one is a colloidal solution. When you can see here true solution and colloidal solution, in true solution, my dear students, particle size is 1 angstrom to 10 angstrom, while in colloidal sol you can see a particle size 10 angstrom to 2000 angstrom. So, my dear students, in colloidal sols are not passed from this SPM, semi-permeable membrane, because their particle size is bigger than true solutions. So, you can see the statement, because in these statements here difference between the particle size true and colloidal solution is there. So, number 1, true particles are able to pass through filter paper and not in semi-permeable membrane. My dear students, it is wrong. Why? Because particle size is lower, 1 angstrom. Now, B, colloidal particles are able to pass through filter paper and not in semi-permeable membrane. Yes, this is your correct answer. SPM, semi-permeable membrane, these colloidal particles are not passed through semi-permeable membrane, but it is a pass through the filter paper. So, my dear students, answer is B is the correct answer for question number 30.